All right, so let's do the simplification here. Let's multiply. We have multiplication. Now this problem can be written without the dot here to indicate multiplication. If you just write it like this, it means the same thing. Also, you could write it like this with the parentheses, and this also would mean multiplication. So there's different ways you could see the same type of problem. So how do I do this type of problem? Well, when you're multiplying radicals, you have the same index here. What you can do, there's a few ways to approach it. You have the same index underneath it. You can combine them to look like this. And now I would have, when I multiply like bases, I add their exponents. There's an exponent of 1 here. 1 plus 7 is 8. And then I would simplify this and I would say, well, the square root of 8, that is the same as x multiplied by itself 8 times. And so we've got how many pairs? We have a square root, an index of 2. I'm looking for pairs. So I've got 4 pairs. So that would give me x to the 4th. They would all get pulled out in front of the radical, and I would have x to the 4th. How else can I approach this type of problem? If you have the square root of x times the square root of x to the 7th, you can rewrite them in this rational form. So remember the index number. I know the index number is not written here, but you can write it in. It's an index of 2. It becomes the denominator. So the 2 goes here, the index goes there, and then the number that you see as the exponent becomes the numerator. There is no exponent written here, so it's an exponent of 1. And so now we have we've changed it from radicals to exponential rational expressions. And now I have like bases, and using the exponent rules, I rewrite the base and I add their exponents. So here, adding the exponents, they have the same index, so the same denominator, and that would mean that the fractions, I can add them together. 1 plus 7 is 8. The denominator stays at 2, and I get x to the 4th when I simplify that fraction exponent. So that is how to approach that. Now, you may see some problems where they look intimidating because there's a lot of information going on. So that one was just a basic one. But what about if I had something like this? You're going to approach it the same way. So we could put everything, when you're multiplying, again, I'm going to, I think a lot of times you're not even going to see that. You're just going to see no operation of plus or minus in between. Just touching each other means to multiply. And so let's put all of this together, and let's put the like items near each other. So 3 times 6, x to the 5th times x to the 6th, and y times y. And so I've got 18, and then x to the 5th times x to the 6th. Well, I have like bases, add their exponents, x to the 11th. And here I've got exponents of 1, so I'm going to get y squared. Can I simplify any of this? So 18 breaks into 9 times 2. I'm looking for factors of 18 that are those perfect squares, 4, 9, 16, and so on. And x to the 11th, well, that looks like this. And y squared looks like this. So 9 I can pull out in front as 3. It's 3 times 3, so that would be 3 up front. And then let's see if I got any pairs. I've got a pair of x's. I have another pair of x's. I have another pair of x's. So how many pairs of x's do I have? It looks like 5 of them. So those will go out front, x to the 5th. And then I have also a pair of y's. And then whatever is left underneath that does not have a pair with it. So the 2 and the x would stay underneath. And so this is how you would multiply and simplify that. Again, you could approach this by changing it all into the rational exponents and simplify it that way too. What if we have something that looks like this? This is multiplication between the two parentheses here. And this kind of looks like a problem that I could FOIL. Foiling means I'm doing some distribution. I FOIL by taking the first terms, multiplying them together, the outer terms, multiplying them together, the inner terms, and multiplying them together, and then the last terms, and multiplying them together. So for the first terms multiplied together, I would get y, the square root of y times the square root of y. So, I mean, I could do the multiplication. I'm going to write it out for you so you can see what's happening. And then we'll do the multiplication. And then the outer terms would be the square root of 5 times the square root of y. The inner terms would be the square root of 5 times the square root of y. And then the last terms would be negative times a positive would be minus square root of 5 times the square root of 5. So let's see what we have here. The square root of y times the square root of y, well, that would be y times y under the radical, and that would simplify into the square root of y squared is y. Then I have plus the square root of 5y minus the square root of 5y. So these have the same index and the same radicand. And then I have 1 and I have plus 1 minus 1, so that zeroes out. So those cancel each other out. And then the last one here, I have 5 times 5. And 5 times 5 would be 25, and the square root of 25 would be 5. So this is what that would simplify to. So we've looked at simplifying radicals. We looked at addition, subtraction, multiplication. What about when you see it in this format? What if you see a 4 divided by the square root of 5? When you see a radical sign in the denominator, we want to simplify this. And we simplify something like this by doing what's called rationalizing the denominator. So the thing is, when you see a square root in the denominator, it is not proper formatting to keep the square root symbol in the denominator. So you do something that's called rationalizing the denominator. And so you multiply, rationalizing the denominator means you multiply both the numerator and the denominator by the radical in the denominator, or the square root in the denominator. So you want to multiply both the top and the bottom by, we have square root of 5 here, so I'm going to multiply by square root of 5 over square root of 5. So take a look at just this. If I cover that up, what is square root of 5 over square root of 5? It's 1. So multiplying this expression, 4 over square root of 5, by this, which is called rationalizing it, you're multiplying it by 1 essentially. So it's not going to change the ratio of 4 over square root of 5. It just simplifies it and clears out that radical from the denominator. So in the numerator, I will get 4 times the square root of 5. I can't combine this any further. This is not under a radical. It would just be 4 times the square root of 5. And in the denominator, we have this square root symbol and this square root symbol, so it would become 5 times 5 underneath the square root symbol. So we would end up with the square root of 25, which we can take the square root of 25. It is 5. Sorry, I wrote the wrong number. I meant to write 5. So this is how you rationalize the denominator, and this would be now the simplified answer. Multiplying, the shortcut here is when you multiply the same number that's under a radical by itself, what it does is all it does is clear the radical. So you end up with 5. It removes the radical. And so that's how you complete a rationalizing of a denominator. If it looks something like this, let's say it's 9 over 5 minus 2 square root 3. This one has a minus sign in the denominator. So if you have a plus sign or a minus sign, you can't just multiply this by the square root of 3 over square root of 3. If you did that, it wouldn't get rid of this square root symbol because of this minus sign. If you did that, you would get 5 square root of 3, and then, yeah, I would get rid of this square root, but then you'd have another square root. So you can't do it like that if you have an expression within an addition or subtraction. Instead, what you have to do is multiply the numerator and denominator by the conjugate of the denominator. So what is the conjugate of the denominator? Well, the conjugate of the denominator, if you have a plus b, its conjugate is a minus b. And if you have a minus b, its conjugate is a plus b. So in this case, the conjugate of the denominator would be 5 plus 2 square root 3. And so I multiply both the top and the bottom by the conjugate of the denominator. And let's see what happens. So in the numerator, I'm going to have this. So I'm going to just write it out. So I'm working in the numerator only so far. And I do this distribution. We talked about distribution in an earlier section. You take the 9 and you multiply it by both items in the parentheses. So we would get 9 times 5, or 45, plus 9 times 2 square root 3, or 18 square roots of 3. So that's what I have up top. Now in the denominator, I have 5 minus 2 square root of 3 times 5 plus 2 square root of 3. So I have to use my FOIL to do this. And this is one of those, you have the same thing, except a minus sign and a plus sign. So when we saw this earlier when we FOILed, what ends up happening to the center term is that it zeroes out. So I'm going to do the FOILing here because I'm running out of time in this video, and I'll do the FOILing and I'll come back and I'll show you what it looks like after I FOIL. So after I FOILed, I get this. And these two center terms are going to zero out. So let's rewrite it without that center term. And then I can take the square root of 9. The square root of 9 is 3. So I'm going to have the same thing in the numerator, but in the denominator I'll have 25 minus 12. And 25 minus 12, let's erase this. Is 13. So this is my answer here. And the goal was to get rid of the radical in the denominator, and we did.